Example 3. We compute the absolute value 2 to the k plus 1 divided by k plus 1 factorial time reciprocal k factorial divided by 2 to the k power. Okay, now you associate one more time factorial k factorial divided by k plus 1 k factorial is cancelled. It's still only k plus 1 in the bottom. This is absolute value 1 over k plus 1. Okay, what's the simplification? This and this. And the simplification, this and this is just 2. It's 2 because 2 raised to the k plus 1 divided by 2 to the k. Division, you subtracting the exponent, and to say k plus 1 minus k is 2, just 2. And we compute the limit. The limit of this on the end of kk, and the variable is k, no m. And that problem, the variable index variable is k. K approaching to infinity of 2 over k plus 1. If you want, you remove the actual value now. Because 2 is positive, k plus 1 is positive. And the answer is 0. And 0 is less than 1. Or it's in between 0 and 1, including 0. Therefore, the series converges by Peters ratio test. Okay, we compute the actual value of the 3k plus 2 because you're increasing plus 1 divided by k plus 1 raised to the k plus 1 time reciprocal this k to the k over 3k plus 1. Okay. Okay, the 3 first. Bueno, es obvio, 3k plus 2 divided by 3k plus 1 is just true. You can separate this like a k plus 1 times k plus 1 raised to the k power. This is 1, invisible. And this together is k over k plus 1 to the k power. And stay 1 k plus 1 here. Okay, perfect. Now ready to apply the limit. We separate into limit when the k approaches to infinity of 3 over k plus 1 time limit when the k approaches to infinity of k over k plus 1 raised to the k power. This limit we did before. The answer is 1 over e. And this limit is 0. It's obvious it's 0, right? Now the answer is 0. Therefore, we prove that this example, this series converges by ratio test. Okay, we compute the expression, actual value, k plus 1 raised to the k plus 1 divided by 2 k plus 1 factorial time reciprocal is division 2k factorial divided by k to the k power. We need to manipulate this. One of these two is cancelled. It's obvious. And k factorial divided by k plus 1 factorial is 1 over k plus 1. And this is k plus 1 times k plus 1 raised to the k power divided by k to the k power. You group it, this is k plus 1. And this is k plus 1 over k raised to the k power. And we have k plus 1 times k plus 1 over k raised to the k power. Entonces it's easy because when you apply the limit, or before you apply the limit, this is cancelled. And the limit that we have is limit and the k approaching to infinity of k plus 1 over k raised to the k power, k so big as c, and is greater than 1, therefore this series divergent. And you prove using ratio test. Okay.